Technosilos, Experimental Pneumatic Conveying Plant PC Car. Pneumatic conveying is the most versatile and complete technology for industrial raw materials transportation, either in powder, granules, or flakes. Technosilos' attention on research and development of new technologies has brought to the new experimental plant PC Car, which represents the evolution of classic pneumatic conveying, adding the possibility of measuring and controlling all variables involved, including those usually neglected. When integrity and preservation of the raw material represent a binding constraint, it is necessary to customize the pneumatic transport with the maximum sustainable speed for the material, as well as to tune up velocity gradient, defined as the ratio between the speed variation and the length of the tubing in which such variation is realized, and mixing ratio, defined as the ratio between material mass and carrying gas mass, ideal to optimize the load losses. The detection and sizing of these values, if neglected, contributes to the physical degradation of the material, such as partial grinding of durum wheat and sugar, breaking of the atomized particles of slurry, and the formation of so-called angel hair, woolly films in the transport of polypropylene. With PC Car Plant, it is now possible to test, measure, and adjust these variables to the appropriate values for the preservation of the product. The plant is made up of compressed air tanks with adjustable pressure, from which the conveying air is taken through a modulating valve which modulates the flow rate. The material to be transported is fed to the pipe by a rotary feeder valve positioned beneath a big bag's emptying hopper. The route is made either vertically, horizontally, upward, and downward, as well as through sections inside and outside the building, in order to simulate all the possible configurations and layout environments. All necessary tools for the measurement of pressure, temperature, and relative humidity are placed along the pipe. Plexiglass pipe sections allow observing the flow of the material conveyed and appreciate the typical shapes taken, like cloud, caps, whorls, etc. The transport ends in a receiving scale hopper with filtering station. The continuous measurement of the increase in weight in the scaling hopper allows calculating the actual flow rate of the solid material. This value, together with that of the mass flow of air, allows quantifying the mixing ratio, first characteristic feature of a transport. With the purpose of minimizing the physical degradation, it is possible to test different transport speeds of the product, modulating the airflux from the storage tanks. The evaluation of degradation is run through a multi-stage sieve available in the same lab. All the factors described contribute to the characterization of the pneumatic transport, making it easy to identify the optimal configuration depending on the location, extent, and physical characteristics of the product.